Welcome back to another YouTube video. Today we're going to be talking about what PWM is, duty cycle, and then we're just going to be writing some codes to test it out. But first, let's go ahead and start with what PWM is. So PWM is pulse width modulation. So basically, it's a more efficient way instead of using a resistor. What it does is that it rapidly turns on and off a light, anything really. Some applications would be to change your screen brightness. Let's say I turn it really low. It seems like we're just like decreasing the wattage of the decreasing the wattage with a resistor, but that is useless. Why? Because, well, it's not useless, but it's not the best. Because whenever you are decreasing the wattage with a resistor, you're also wasting some energy, So what people do, or Apple does, is they add a PWM. It basically just turns the switch of the LED on and off very fast so that it looks like it's so fast that our eyes cannot see it going on and off. It just looks like a continuous light, making it glow lower, so it just looks really dim. So what duty cycle is, it's basically just how much the LED or anything really goes on and off. So how do we find out the duty time? So on time upon total time. In this case, our total time would be 255. So let's say that our on time is 44. Okay, then, that doesn't really make much sense. Let's start off with something more simpler. Let's say that the LED can be turned on for 4 milliseconds. So that would be 100% duty cycle. So it stays on for 4 milliseconds, and the total time it can stay on is 4 milliseconds. So we would do 4 divided by 4, which equals to 1, times 100 is equal to 100. So it's 100% duty cycle. In this case, our total time is 255. So our total time is 255. Let's say we wanted to stay on for 127 milliseconds. Then we're going to put it as 127. Now we divide it, and it's going to be approximately 50. It's not going to be exactly 50. It's like 49 point, yeah, it just keeps on going on. It's approximately 50%, and then it's like 0.5008, and then also if you multiply that by 100, it's approximately 50%. So the same thing happens with 191 and 0. So what this basically I'm showing with this table or graph is that I'm showing the duty cycle, so 0. It's just staying at 0 voltage the whole time. It's not turning on and off. 25% duty cycle. It's staying on 25% of the time and then going off 75% of the time. Of course, it's not accurate, but I tried my best. But yeah, so 5 voltage is the max in our case, and 0 voltage is the lowest. But using this duty cycle, we can change it to 2.5 volts and all, just like here. So if we use our computer, let's just use it as an example. This is 5 volts. It's bright. We turn it down about halfway. This is 2.5 volts. You see? So using duty cycle, PWM, it's much more easier it's much more efficient, fast, and easier to make our LED light lower or dimmer or brighter. But you can also use it for other stuff. So let's say you have a PC at home. The cooling fan that makes sure that your PC doesn't explode while you're gaming midnight, that uses PWM. It's just going on and off really fast or really slow, either to make the fan faster or make it make less noise. So you can use it for anything, even for like a drone. Like you can make it faster by making the wings or turbines spin faster, and you can make it go slower by making them spin slower by just turning it on and off extremely fast. And by fast, I mean really fast. So we're just going to be writing a code to test it out. and some kind of notes. So first thing is that the equation defined duty cycle is on time over total time times 100. So just like I said in the start, let's say our total time is 4 milliseconds. Out of that 4 milliseconds, it's on for 4 milliseconds. So that would be 4 upon 4. So 4 divided by 4 times 100. So 4 divided by 4 is 1 times 100 is 100%. And we're just going to be using examples later onwards, like let's say 234, 197, and like that. So to be more specific, I'm going to be using 0, 6, 127, and 255. Now we already know 127 and 255, but it's important that we really understand how to do the equation. So I'm just going to be showing y'all the work on paper. So first, to write the code, we have to write analog, right? Not let's say not digital right. Digital right is used whenever you're using a resistor just to turn it on or off. Like, yeah. But analog right, you don't need to do all that. You just go right over here and you change the brightness. So analog right is used for PWM and digital right is used for other. So over here, I just wrote some other examples. So if on time is 1 millisecond and off time is 3 milliseconds, we don't know the total time. So we know that's on for 1 millisecond upon total time. We don't know the total time, but we know that if we add the on time and off time, then that equals to the total time, which is 4 milliseconds. So it's 1 upon 4, which is 0.25 times 125%. So that's the duty cycle of this right here. And then let's look. Yep. You don't need to write all this down. This is all you need to see for now. That is just a bunch of mess that I made. And for here, we're using 8 bits. So what are 8 bits? So it would be, so remember 2 bits, so 0, 1. How many combinations could we make with that? 4. And each 0, 1 represented like 0 to the power of 1, and then, yeah, right? So 8 bits is now we're using 8 bits, so that would be 1, 1, 1, 1, 1, like that. So that would be 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. So the maximum that we can get with 8 bits is 256. 2 to the power of 8, 256. 256. So basically how I found that out is that 0, 0, 0, 0, 8 times and then 0. So it gives us a total of 8 combinations, 0 and 1. We got to use 0 and 1. So we have to write it 0, 1, 0, 1, 0, 1, 8, and we get to write it 8 times. So this kind of, you probably can't understand how I'm saying it. So basically what I'm saying is 0, 0, 0, 0, 0, 0, 0, 0. Now 1, 2, 3, 4, 5, 6, 7, 8. That means that I can only write it 8 times. Now this could be either 0 or 1, but it can't go past that. So it could be 0 or 1. So it could be 1, 1, 1, 8 times. But it can't go past that. It could be 0, 1, 0, 1, 0, 1. Now we have to see how many total combinations that we can get using this 8 bits, using 0 and 1. Now, you're obviously not going to go counting each and every single combination. That just takes too much time. It's a humongous time waste. So easier way is just to take 2, and we're using 8 bits, so 2 to the power of 8, which equals 256. Now, why is 255 the total time if it's 256? Because we're going from 0 to 255. Now you're going to be saying like, okay, well, 0 gives us an extra 1. So 0, 1, 2, 3, 4. You see how my 5 fingers showed up whenever I said 0 to 4? That's because 0 gives us an extra number. So it would be 0 to 255. Now, duty cycle. Now this is where we're going to find out how much it's on. So we know our duty cycle. It's 30%. How much is x? X is our on time. So x upon 255 times 100 is equal to 30%. Now all we have to do is take it over here. We have to multiply it by 255 and then divide it by 100, doing the inverse operation. Taking it on this side, dividing it by 255, I mean multiplying it by 255 and dividing it by 100, and that will give us our on time. Now we're gonna get to how to build our circuit, which is insanely simple. It's gonna take you about 5 seconds. So one more thing. So I don't know if y'all can see it clearly, but yeah, there we go. So digital parentheses PWM curly line. So that now it shows that because if we're doing PWM, then you can only use the digital pins with the curly line on the left. So like 11, 10, and 9. Those can be used because they have the curly line on the left. While 8, 7, 13, and 12 don't. So we can't use that for PWM. So you got to remember that, because if you don't do that, it's obviously not going to work. So you got to remember that the long line of the LED is connected to the digital pin, while the shorter line is connected to a resistor and then ground. Now you're thinking, if we're using PWM, why do we need a resistor? Well, PWM doesn't lower the voltage. It's going to be the same voltage, it's just turning it on and off repeatedly. So that means that if we have enough voltage, then the LED could get burned and it's just going to destroy it. So it would be much better and safer to still use a resistor. So now we're going to get to the code. The code is also extremely simple. It's easy to understand. So basically over here, we're naming LED equals 9. So let's say that I accidentally wrote 8 as my pin number. Instead it was 9. I would have to change it everywhere that I wrote 8, which you don't want to do that. So you just want to name your digital pin something like digital pin, and then equals to 9. So int LED equals 9. Then our void setup, we said pin mode, naming it whether it's input or output. In this case, our digital pin is output, so LED is output. And then analog write. This is a little bit different. So whenever you are using the analog write, you got to write your digital pin there, which is 9, which equals to LED. So we put LED there, comment, and then we got to put a value. Now remember when I told y'all it was 255, but it could go from 0 to 255. So 255 is our total time, but we can also go like 64 and all. So like if we want to make it dimmer, we would go somewhere like 64 or 10, meaning that's only on for 10 out of that 255. So we can change the value like that. So let's compare it. So right now it's at 64. It shines about this much. Now let's change it to its max, 255. Also, don't forget your semicolons. That's extremely important. I've done it about 1,000,000 times, and I've always had to go in, write the semicolon individually, and it was hella annoying. So you just want to remember that. Okay, it's done compiling and uploading. And yeah, I'm pretty sure y'all can see the difference, because I can see the difference, and it's much brighter. And if y'all cannot, I'm just going to write 0 here so that y'all can see it much more clearer difference. So upload, completing search, uploading, and it is done. And then let's see. Yep, it's not turning on because it's 0. That means it's on for 0 out of that 255. So yeah, hopefully y'all learned something new and it's interesting from this video. Come back for another, and hopefully you enjoyed. Bye bye.